This is number 15 off of the molar concentration handout, and this is using molarity in stoichiometry. So we talked about how molarity can be used to calculate moles of a solute that's available in a solution. And so remember, stoichiometry is the heart. The heart of stoichiometry is moles. So basically, we're going to be using molarity as a conversion factor in our stoichiometry. So we have barium nitrate reacts with aqueous sodium sulfate to produce solid barium sulfate and aqueous sodium nitrate. Okay, let's get an equation down first. Barium nitrate, barium has a charge of +2 because it's in this column. Nitrate is NO3 -1. So I need 2 nitrate ions for every 1 barium. And it's getting together with sodium sulfate. Sodium has a charge of +1. Sulfate is SO4 -2. So you need 2 sodiums for every 1 sodium sulfate. Or for every 1 sulfate. And we're making barium sulfate. Those both have a charge of 2, so those cancel out. Sodium nitrate, those both have a charge of +1, so those charges cancel out. But it's not balanced. We have 2 sodiums on the left. We're going to need 2 on the right. We have 2 nitrates on the left. And now we have 2 nitrates on the right. Everything else looks balanced, so just put a 1 in front of them. So Abby is placing 20 milliliters of barium nitrate in a flask. She has 20 milliliters of this guy. And we have a concentration here, 0.5 molar. She has a 0.225 molar sodium sulfate solution available. So it looks like we're looking at this guy. She has the solution of this guy ready to go. What volume of the solution must she add to her flask of barium nitrate so that she has no excess reactant left over? Okay, so it's a lot of numbers here. But what we have to remember is that in a reaction, we're trying to relate this and this substance. And the only way we can do that is through their mole ratios. So for every 1 mole of barium nitrate that reacts, it's going to react with 1 mole of sodium sulfate. So we first need to figure out how many moles of barium nitrate we have. Think about how many moles of sodium sulfate that will react with. And then figure what volume of solution will contain that number of moles. Okay? So, again, we're going to be starting off with our barium nitrate, 20 milliliters. We need to find moles of that because that's the heart of our stoichiometry. And to do that, they gave us the fact that every 1 liter of my barium nitrate solution, that contains 0.5 moles. So we're going to use that piece of information to convert between volume and moles. Once we get our moles of barium nitrate, we can figure out how many moles of sodium sulfate we have. And we need to react with that many moles of barium nitrate using the fact that it's a 1-to-1 mole ratio. That's easy. From there, they asked about volume of the solution. So this isn't a solid, it's in a solution. And we know that in that solution, every 1 liter of it contains 0.225 moles. Okay, so these are the steps that we're going to take. So let's figure out how many moles of barium nitrate we have. So if I want to use the concentration of the solution to figure out how many moles are in 20 milliliters, I need to convert my milliliters to liters by dividing it by 1,000. So 20 divided by 1,000 should get you 0.02 liters of my barium nitrate solution. And in that solution, every 1 liter has 0.5 moles. But I don't have a full liter, so I shouldn't even get the full 0.5 moles. My liters cancel out, and I find that I have 0.01 moles of barium nitrate. Now, to convert that to moles of sodium sulfate, I use my ratio. Every 1 mole of barium nitrate requires 1 mole of sodium sulfate to react with it. So we should have 0.01 moles of sodium sulfate that we need. Now again, it's not a gas, it is not a solid, it's in solution. So we're going to measure how many moles are in a solution using its molarity. So in this Na2SO4 solution, we know it's 0.225 molar. Or in other words, every 1 liter of that solution contains 0.225 moles. And I put my moles on the bottom so that they can cross cancel. So I take 0.01 divided by 0.225, and I should get 0.0444 liters. Now that is a really small number in terms of liters. If we turn that into milliliters, there are 1,000 milliliters in a liter. To multiply that by 1,000, you should get 44.4 milliliters. So again, let's reflect on what just happened. We have 2 solutions. One's barium nitrate, one is sodium sulfate. And we're going to mix them, they're going to react. So we want to figure out how much of each solution do we need to get that perfect reaction. Well, we know that we're going to deal with 20 milliliters of the barium nitrate solution. So we need to figure out how many moles that is. So I can use the concentration of that solution to figure out that, oh yeah, in 0.02 liters or 20 milliliters of that solution, I have 0.01 moles of my barium nitrate. And in the reaction, it reacts in a 1-to-1 ratio, so I need 0.01 moles of sodium sulfate to react with that. But they didn't ask for moles. I have a solution. So I need to figure out what volume of that solution I need if I'm going to react 0.01 moles. Now that solution has a different molarity than this other one. This solution's molarity says that I have 0.225 moles for every 1 liter. So I can use that to convert between moles and liters. So I put my moles on bottom, cross cancel, and I figured out that I needed 44.4 milliliters of my sodium sulfate solution.